Assalamualaikum and hi. My name is Muhammad Fayyad Nur bin Nur Najhan with the matrix number AA200058. In this video, my friend and I will present our answer for the secretary assignment. Okay, for the first question, one moment, we need to find I2. First of all, we label all the resistors R1, R2, R3, R4, R5, R6, R7. Next, we assume that R2, R3, and R4 as delta, and then we convert to Y by using the delta Y formula. And then we get the answer RA equal to 3 ohm, RB 18 ohm, RC 6 ohm. Okay, next we sketch the new circuit. From here we know that 35 ohm are series with 3 ohm, and when we plus both equal to 38 ohm. Same goes to 18 ohm are is series with the 130 ohms, and when we plus both equal to 148 ohms, and 6 ohm and 135 ohm are series, and when we plus both equal to 141 ohm. Okay, next we find R equivalent. From here we know R1 plus R2 parallel with R3 plus R4, and we get R equivalent equal to 136.21 ohms. Next, by using the V equal to IR formula, we find IT, and IT we get 3.67 ampere. Okay, when the all information needed, and we get I2 equal to I6, which is 148 divided by 148 plus 141 times 3.67, and the final answer I2 equal to 1.879 ampere. Next, second Roman, we need to find I1. From the circuit, we know that I1 equal to I4 plus I5. Okay, so what we do, we find the V4, which is V, and we get V4 equal to negative 20.958 volt. After that, we find I4, and we get negative 0.349 ohms. Lastly, I1 equal to I4 plus I5, and the answer is I1 equal to 1.242 ampere. Okay, for the third Roman question, which is we need to find the value of V, but we has done find it during do the second Roman question, which is at here. Okay, so we can go through to the last question, which is for Roman. Find the power supply and voltage source. Okay, by using this formula, power equal to voltage times current, we insert the value, and the final answer we get power equal to 1835 watt. To prove our answer, we run the circuit at multisim. Okay, this is for question 1, this question 2, question 3, and question 4. All answers are same with our answer. That's all from me. Thank you.
Hello and good morning everyone. My name is Meghin Thiran, son of Subramaniam. The reason of this video is to explain on how to solve question number 2 of circuit theory assignment 1 using nodal analysis. And this is the circuit, and I'm going to show on how to find V1, V2 and V3 using nodal analysis. Firstly, we look at V1. First, you need to know which current is flowing in and which current is goes out, and you must use KCL to find V1, V2 and V3. So come, let's identify which current is going in and goes out in V1. So the current goes in is I1 and the current goes out at node 1 is I2, and then I3, and then I4, and then I5. And these are the working that I've done for node 1, node 2, and node 3, and the further explanation. Okay, let's look at V2. I mean node 2. The current goes in is I7 and then I3 here over here. Then the current goes out is I6. And lastly is node 3. I mean V3. The current goes in is I8 and then I4 over here and I5 over here. Then the current goes out is I7. So basically KCL, to use KCL is we must identify which current is going equals to which current is going out. It means this is the nodal analysis. So in nodal analysis you must use KCL and use calculator to find V1, V2 and V3. V1 which is 10 volt, V2 which is 4.9333 volt, and V3 which is 12.2667 volt. And one more thing is, it doesn't matter that the labeling of I1, I2, I3 and I4, I5 and so on. It's matter that you need to identify like which current is going in and equals to which current is goes out. That's the matter. That's the important thing that you need to find. I just want to explain the working of node 2 because since it's a smaller working, so I just explain briefly. I3 plus I7 equals to I6. So I3 and I7 goes in and I6 goes out. So if I3, this is I3. So V1 minus V2 over 8 because the resistance flowing over here is 8, and V3 minus V2 over 4 because this is V3 minus V2 over 4 because the resistance flowing over here is the current flowing across the resistance is 4, and equals to V2 over 2. So this is V2, then this is 2, and this is the simple working that I can show briefly. And these are the schematic diagram of question number 2 circuit theory, and these are the current source flowing over here, and these are the resistance, and these are the DC power, and this is ground. So the answer which I have done and the answer over here are the same, which is this is V1, this is V2, and this is V3, and consider the ground is considered as V4, but since V4 is equal to 0, so we doesn't need to include that. I hope that I have explained better in multisim and also working that I have done, and that's all from me. Thank you.
Hello everyone, my name is Tar Meganraj, son of Nadrasan, and my matrix card number is AA201143. So let's get into it. My question here is number 3, and I'm going to tell you how do they solve these questions. So what I could see from this question is, by looking at this question, I do know that I have to do super mesh, but then super mesh is normally by doing the first loop, second loop and the third loop. So what would I want to do here is, I would like to name this loop here as IA, and this one as IB, and then this one as IC. Okay, now I have 3 loops, but then what the tricky part here is the dependent current source, which is here. So by effectually, when there is a dependent current source, the loop divided will be different. It will go like this. The first loop would go like this, and then the second one would go like this. So first of all, I found my first equation here for the first loop by doing comparisons of 2 different loops, which is IA, IB, IC, and the other one. So the first equation for the first loop here is 7IE minus 15IB plus 30IC equal to 0. For the second loop here, and the second equation is negative 5ia plus 17ib minus 10ic equals to 40. And I used something here. This is my supporting equation. So I created my supporting equation by comparing and seeing the other loops by doing like this. So IA goes here and 4.3 ID goes here, and it comes out as IC as I shown here. And same goes to ID. ID equals to IB minus IA, and that's how I got my second supporting equation. So now by having these supporting equations, I can solve my variables, which are IA, IB and IC. And what I did was I substituted equation 3 into equation 1 and 2, and I got my values for IA, IB, IC, ID and IE. These are my values for IA, IB, IC, ID and IE, and this is my working to obtain those values. This and here, this is my substitution method to find IA and IB. So now we are going to go for the next part, which is part B. So what they would want me to find in part B is they want me to find total power equals to total power dissipated. So the total power source, which is the total power developed, which is 200 times by negative 4.6 here. 200 times by negative 4.6. And how I obtain that is by taking the power going through here and times it with P equals to VI. So now I got the power source, which is the 920. So now I can find every other resistor's power, for example 10 ohm and 25 ohm, by using P equals to I square R. So these are my values for the power of the resistors here. These here. And then I want to find my power for 4.3 ID, and I could not find it in a normal way. So what I did was I manipulated my circuit here into this one here. So this circuit makes my job way more easier to find the power at 4.3 ID, and the power at 4.3 ID is 399.69 here. And lastly, what I did was I added all the power here, which is considered as power dissipated, and then I minused it with minus 399.69. and lastly, so I got 920 for power dissipated and negative 920 for my power source. So the sigma power here will be negative 920 plus 920, which is equals to 0. So this will be the working for these questions, and the next will be my multi-sim representation. Here this is my multi-sim representation, and these are the values given, and all my values are correct. And that's all from me today. Thank you so much.